Welcome, everyone. Thank you for taking the time today to join me for the virtual webinar. We're going to be spending the next half hour on some strategies and activities that you can use immediately following the session to assist you in teaching about environmental earth and biology science. I'm really excited to share what I have planned for today, and I hope you can try some of these different resources out with your students. If you have attended one of my past webinars, you might already know how I like to begin, which is gauging my audience and their interests. So I'm going to run a quick poll. And the webinar is intended for K-8, but this poll will really help me better understand who is watching today. So I'm going to run that poll. Please take the time to fill this out. You should see the poll on your screen now. Anyways, for those that are joining us for the first time, welcome. I appreciate you taking the time to join my session. Feel free to write in the chat box and introduce yourselves to others on the webinar. I'll try my best to monitor chat as I present. I did put that up there and it said hello in the chat box as well. But then also keep in mind, we are recording this webinar. So if you missed the live session or you were watching or rewatching this webinar, you can certainly look at the recording. And then there will also be a survey following up the webinar. So please take the time to fill that out. We use this feedback to improve our webinars. So let's take a look real quickly to see who's filled it out. Looks like we have majority with us today elementary, but we do have some middle schools as well. Awesome, great. All right, so let's jump right into the agenda. To begin, we're going to briefly talk about phenomena. I think this plays an important role whenever we're thinking about science, but especially when it comes to environmental earth or biology sciences. It's kind of the foundation for model-based inquiry. So I think this is like a really good starting point. Then we'll jump into some different resources you can use or share with others. While I go through some of these, feel free to share some of your own activities or ask questions along the way in chat. I'm always open to hear and learn more about what others are using in their instruction. And then finally, we will wrap up with some time for Q&A at the end. We do have only a half hour today, and it's going to seem like the webinar is going to go by rather quickly. So make sure to also ask questions along the way. All right, so what makes a good anchoring phenomena experience? I want to see or hear what everyone watching today thinks. Write your answer in chat right now. What qualities should someone be looking for? It could be brief and you can say one thing. You don't have to feel like you have to elaborate. My intent today is to level set and make sure everyone is on the same page. We're going to kind of set the stage together and then progress into anchoring experiences some more. So I'll wait for some people to write into the chat box to share some of their own experiences. All right, while you're thinking about that, writing that down, I do want to kind of keep moving as well. So just make sure to write that down. We'll continue on with our presentation as well. So leading students to learn and explain phenomena is what science is all about, right? And so it is about anchoring that understanding. It helps students really begin to understand the world around them, how things work. So it's critical that us as educators are able to recognize productive phenomena. Yet anything that occurs in the natural world is a phenomenon. A classroom phenomenon might be a case where there's an infestation and now we have to build a solution to the problem. It could be something that is puzzling, like, hey, why isn't rainwater salty? It could be a wonderment. How did the solar system form? It could be collected data that reveals an important pattern. How have the number and types of species changed over time? And there's so many more examples. So how can you tell a good phenomenon from an unproductive one? In order to tell the difference, just like with data collection, we need a rubric or guideline to quickly assess whether it is a good phenomenon. If you haven't used this strategy before, I've listed some examples on the screen for you to kind of think about when building a framework. Does it have scope and sequence as you develop lessons around the phenomena? Is it something that someone experienced, just like when COVID-19 hit? This was a great world understanding of how vaccinations came to be and why is it required by our school? Is it something that can someone can do some research on the internet, or does it actually require more explanation and study? This criteria will really help you quickly assess whether or not the phenomenon meets student needs as well. But however, I am a realist. We have to be realistic and realize that few phenomena will actually meet all of your criteria. So choose specific criteria that the phenomena needs to have, and then you can begin to avoid unproductive phenomena in your science classroom. So this concept, a good phenomena experience, ties into modeling. So how do we successfully build models that represent our own understanding? We all know that models have limitations, right? So the goal is to let students experience how using a model can make communicating about complicated phenomena much easier. We can show that if we simplify the real world into a system. We can describe that system through a model. The focus needs to be on how the model helped communicate about the phenomena, not identifying the boundary, the inputs, the outputs, the parts, the relationship between parts, or flow of material within the model. We simply intend to give students an experience centered around a system model's power to simplify and communicate complicated ideas. So let's get into more of what that means. I have some examples that I wanted to share with you today. The first one might seem bizarre, but just bear with me and I'll explain. We're going to watch someone show us how to tie a knot, but we're going to focus on the topic systems and the system models. So systems and system models is what our focus is going to be. Systems are, of course, tools that scientists and engineers use to understand complicated phenomena and problems. A system model is a tool used to visualize and understand the system. So a system model should show all the parts or components of the system and show how these parts are related to one another. So let's quickly go into this little YouTube video right here.
Another knot I'm going to show you is called the tugboat bowline. And it's similar to the regular bowline. It's a little different. And it's tied in like an emergency situation. If a man fell overboard and you had to throw him a line, you don't want to just throw him an empty end. You want to have a loop on the end of it. It's also handy if your boat's coming up and you need to throw it over a mooring. This knot is tied in a split second. It's hard to show you in slow motion, so we'll have to slow the film down for you. But you stand on your rope, you simply flip it around.
And this is where the part where they're showing how slow motion it goes. As you can see, it's a very, very quick tutorial in how we actually built this knot. And so they try to really slow this down for you to visualize.
That quick. Show it again to you.
So the gentleman right there basically shows it really quickly how to actually build that knot. And let me pull up. So, but how does this really apply to system and system models? Well, it's rather simple. Okay, so basically what it does is before introduced to video, you would give some examples of when the students and or you needed to tie a loop into a short length of rope. It can be seen at a rodeo, or it could have been from another experience. Then you would watch this video and give the students approximately about 2 feet of cotton rope. And keep in mind that this video is meant to be at an advanced level and they're meant to struggle. So again, we're trying to get them to understand that there is a simplified way of communicating the same concept, which is building a model. This activity probably would be more so for the middle school level though. So just understand that this is just one example for more of like the middle school students. There's definitely other examples that you can utilize, but this just happens to be a middle school example. So here's a model. This model one, students then, try to attempt to make this knot using this model and then discuss as a class, hey, is this model helping you learn how to tie the knot? Why or why not? Is there anything else that could be added to help you tie the knot? Maybe step-by-step photos? Okay, all right. Well, how about model two? All right, as you can see, now students can start to connect their prior knowledge and current thinking to their experience tying knots by thinking about the questions that you ask, right? So, which was more useful, the video, model one, or model two? Why is simplifying the scenario important and when explaining how it works? Can you oversimplify? So then you can go back to the original question of, what is one way to understand how complicated systems work, right? The results being models. So this is getting that framework of why do we actually use models to help explain different phenomena around here. So it's all about building that understanding of why do we actually use models. So it's just a nice concrete way for students to actually conceptualize the idea of why are we building these models instead of saying, hey, we're just doing this activity just because. And we're going to show up a model or build a model. And then you have to explain to me what that model is. So it just kind of takes this different avenue of the why behind we're building these models. So the next video is actually going to be women explaining how a water slide works. This can be a good phenomena video for students learning about gravity. So I'm going to actually click on this real quickly, and it's going to be the same thing. I'm going to pull this up real quickly.
The water helps to move you down, and it also makes you go faster and stops you getting stuck. But where does all that water come from, and where does it go? Let's find out. How does it work?
A water slide.
When you go on a water slide, the first thing you need to do is climb to the top. Now this is the top of the slide. And can you see there's lots of water running down it? This is what's going to help me slide down. First, I need to sit down like this. All I need to do is push off. But first, I'm going to put my special camera on my head so you can see exactly what it looks like as I go down the slide. Are you ready? The water is going really fast and taking me with it. It's good my special camera is waterproof. That was so much fun! Did you see how the water was carrying me down the slide? The water is always flowing downwards, and when you go on a slide, you go down too. And that's because of something called gravity.
All right, so as you can see, it's not until the end that students really hear about what they are actually learning about. She says, as water goes down the slide, you do too, and that's because of something called gravity. And your first thought might be, well, what about gravity? How does gravity affect me going down the slide? If you're a little more keen, you might think, hey, is that all that is affecting someone going down the slide? What about friction? Like I said earlier, it just opens up conversations so you can begin to think about productive phenomena and unproductive phenomena. This video has some good elements, but does it meet the criteria you are looking for? So that's the framework that we're kind of have in mind. And you can use this again with elementary students, because those that haven't experienced a water slide might not understand what it actually looks like in a water slide. So again, different ways to be able to use that anchoring phenomenon. All right. Here are some resources in case you wanted to look for some anchoring phenomena. I think it will kind of spark ideas and allow you to kind of be creative in using the content. So Wonderopolis is a great way to kind of show some just natural curiosity and things. That's where I kind of got that gravity phenomena that you just saw with the water slide. Let me pull up this link for you to kind of show you a little bit easier what I'm actually talking about. So this is Wonderopolis. So it does a really good job of just having some backgrounds, exploring wonders. What are you wondering? Just different kind of questions that you'd have day to day, right? So, hey, if you saw this different activity, how do you actually do that, right? Why do kids need braces? What color is camouflage? Some different things that you can actually use to test. So you can go to explore wonders. You can actually go into a science specific kind of topics if you wanted to. and just kind of look at these different areas. So, how far away is Proxima Centauri, right? Or why do cicadas emerge every 17 years? That is so bizarre. So all these different things, and there's my example of how does water slides work. So these are good things to kind of introduce to students for some different anchoring phenomena. All right. The next one I have here is Science Buddies. So Science Buddies is kind of nice because it kind of gives you the introduction to the actual topic itself. This is oftentimes used to kind of spur ideas for science fair activities. It kind of gives sometimes an introduction video, really quickly synopsis of showing the actual experiment itself. So you kind of get an idea. But this can definitely spark some interest or conversations around some different phenomena as well. And then finally, you also have something called phenomena for NGSS. This guy likes to, or this individual likes to refer to themselves as NGSS Guru Hub. So this is just a great way to start talking about some different interactions, different things that kind of occur over time. Hey, look at this. There's a sensitive plant. Why is it moving like that? That's kind of bizarre. This isn't like a carnivorous plant where it actually encloses on the actual insects, is it? So the Venus flytrap might be some other variation that talks about things that are sensitive. So there's just a lot of good things out there that allow you to be able to interact and use for your classroom. So I just wanted to share those different resources with you. The next thing that we're going to get into are some different content activities that you can use. The first resource is from something called MyStar, which is a middle school curriculum that supports the next generation science standards, also known as NGSS. But it really does a good job with was empowering students to kind of use the science, but also the engineering practices to address real world issues. So they provide excellent professional learning for teachers implementing their curriculum, both virtually and face to face. That's how you get into the program, basically. They assist with the learning of their program at no cost, but that's kind of a requirement to be able to utilize this. This is also where I kind of got that tie the knot example. It was a part of off the shelf lesson that they do provide. So if you do like that kind of ideas, that's something that could be very good for you. Just to kind of give you an idea of how this is actually broken down, they have different units, and each of these units are used over the course of semester. You can see that each of these have a theme, and you can kind of see like this color coded theme for around it. So sustainable ecosystems are right here for 8th grade. If you have built environments, that's for your 6th grade. Moving thermal energy, and also how sound and light feed our senses. Those are also different additional contents. So then in the second semester, you'd be doing a variety of other different units. And again, having the engineering design practice all within there with the content standards makes it very easy and convenient to be able to run it off. Each unit also has something called a summary, which kind of gives you an overview of what's going to be covered, the kind of a challenge question, kind of real world application. That's where it's designed around. And all of these are tied to around current issues. So content, the challenge, everything is something that's current, that's relevant. They also do a good job of having something called lesson sequencing. So knowing when to do which lesson and activity when to help out with the time management. Let's go over an example of one of these. One of the units is called Keeping It Fresh, What Plants Need to Grow. So this unit focuses on how obtaining fresh food and consuming enough of the proper vitamins and nutrients has been a problem, right? So before we had, these mass production farms, there were diseases that kind of plagued explorers and settlers. But in more recent times, there's also been similar issues still occurring for like space exploration and extreme environments like Antarctica, who are forced to eat mostly frozen, processed, or freeze-dried foods. So the problem of being able to continue to grow food on site has dramatically increased in popularity as more people move to these environments. So how do we implement this idea is not necessarily straightforward. So that's where this kind of framework of this unit actually comes in. So in this unit, students are going to be examining how environmental conditions, resource availability, competition, and genetics affect organism growth and reproduction. The students will be participating in an experiment to understand the impacts of these factors and plants grown in the classroom, as well as practice, developing predictions and making claims supported by evidence and reasoning. So just to kind of give you a better idea of what this program looks like, I figure we might want to jump to the website just to kind of show you a little bit more. So this would be an overview of, what do plants need to grow, keeping it fresh. It gives you a video synopsis of it. Here's a link to the overview, some additional resources that you need. Here's that overview. Again, having that summary, that challenge question, the related problems, then the lesson sequencing. Okay, days 2 to 4, these are the types of things you're going to be doing. Days 3 to 4, we're going to also include these. 4 to 6, we're going to potentially include these. But you can have these, and it's kind of more or less like a pacing guide, right, to kind of help you use these units. They do have off-the-shelf type of lessons as well. This is what it looks like. So it has how many periods it would be. It'd be having all the performances, the contents, the learning, NGSS connections. Then it gets into the introduction. So all the things that you would need, some background, summary, some teacher notes as needed. Eventually they get into, so this is where that system and system models topic came from. But then they also get into the Rube Goldberg machine, and then talk about how does that also tie into systems and system models. So it just does a really good job of tying it all together. They have a variety of different units. They are middle school specific, unfortunately, for those that are elementary on this course. But I did want to just offer one resource out there for you if you were interested. Okay. Another resource to kind of consider is the CK12. This is really nice because, again, being a free resource, they do allow you to kind of build classes and integrate with other designs. So I'm just going to click on this link right here to pull up this right here. Okay. So I'm going to pull this up just to kind of give you a better idea of what this actually looks like. So here's your dashboard. It gives you a variety of different topics that you get to pick and choose from. If you want science specifically, if you want grade level specific as well, you can do that. Kind of gets into, okay, what are you really looking for? So there's a variety of different subjects, not just only science. So if you wanted to extend that, they do have multiple languages too. So that's also a plus whenever you're implementing. Then you can jump into each of these different units. So this happens to be Earth Science unit. They have a variety of different topics. If you click onto here, remember we talked about gravity a little bit. So if we clicked on that erosions and depositions by gravity, it gives you the lesson objectives, vocabulary, it gives you introductions. All the different figures are all included within here. They have any additional resources as needed. They have additional details. If you want to talk about, hey, who is the author or how would you actually use this? And then the attributions as well. So everything's on there. It makes it very easy to utilize. They do also have a variety of different learning capabilities as well. So here's an interactive piece talking about living and non-living things. Okay, so we know that living has, it grows and develops. Well, if it cannot respond to the environment, we know that's non-living. If it's not capable of reproducing, we know that's non-living. And so we get to be able to utilize this, giving some background information, use the simulation to help out with, and then you get some challenge questions as well. So this is called part of their Plix series. That's also part of their program. And then they also have additional content in other areas. So this happens to be an elementary version of Gravity, a little bit at the second grade level. So just, again, very nice resources to be able to utilize. You can build your classes on it. It's got reinforced learning. So it has something called adaptive practice, where students learn concepts through a regular personalized practice. They have study guides, sometimes developed by students to kind of help be the same language. They also have, of course, that interactive learning, that Plix, which is play, learn, interact, explore, as well as simulation. So they have chemistry and physical simulations too. So just a great resource for educators to be able to utilize. Other things I think you can consider too, some news and events, live science. So around environmental, talking about actually engaging and actual real articles in real time, real events. This does a really good job. So if you want to see what's current in science, live science, I would suggest is a really good resource. So on different articles and updates in that realm. We also have, of course, the National Association of Biology Teachers. Maybe you probably heard of this already. But they do have a variety of different resource links beyond just if you are a member. Then they also have, of course, the EPA, which also has a variety of great teacher guides and lessons that they can utilize too for these different areas as well. I know I kind of went through this a little bit quickly. I know, as like I said, it was only a half hour. I did want to leave some time for some Q&A at the very end. Thanks for everyone for joining me today. My name is Jordan Nelson, and I'm one of the customer engagement managers with Nasco. If you have questions, you can ask them at this time. As you're writing them or thinking of them, I did want to reiterate that there will be a survey after this webinar, so please take the time to fill that out. If you're watching this recorded version, you can reach out to me at engage@nascoeducation.com, and I'll get you any kind of this presentation from this recording. You'll also be receiving a follow-up email for those that did participate that also will have this presentation with all the links in it as well. So make sure to check your spam folder just in case you don't see that. It should be arriving within the next day or two. Thanks again for everyone attending. It doesn't look like I have any questions, but it's not to say that you can't reach out to me if you do have any of those. I hope you enjoyed this session, and I hope you have a great rest of your day. Take care, everybody.